Guys. Um, right, so we're going to finish off this chapter today. The other day we spoke about the moon. So we spoke about the Earth spinning, and then the Earth spinning around the sun, and then the moon spinning on its own orbit and orbiting around the Earth. And then we were talking about in the way that the Earth rotates, that's how you get your seasons. Okay, so that's pretty much what we were talking about the other day. It was largely, we did mention the moon slightly, but it was largely about the Earth rotating on its own axis and then revolving around the sun and how that orbiting of the sun creates the seasons. Okay, so today, if I could get to it, here, we're going to talk a lot more about the moon. Okay, so I suppose a couple of important points to note. I'm going to show you quite a few videos here. A lot of this is, it's hard to explain anyway, but it's really hard to explain when you can't see me. So I would have used videos in class as well. Okay, so the moon is referred to as a natural satellite. We've talked about natural satellites before. So a satellite is something that orbits another body. And then a natural satellite is not man-made. So there's plenty of satellites up there for telecommunications and stuff, but they're not natural because they're man-made and they were put into orbit, whereas the moon is a natural satellite. It was not man-made. Okay, the orbits are important. So it orbits the Earth every 27.5 days, approximately 27 days. And as it orbits the moon, it rotates on its own axis in the same time. Okay, that's important. So it rotates on its own axis. So basically, it takes 27 days to go around the Earth. And during those 27 days, it only turns once all the way around. Okay? It's an important point because I don't know if you've heard that phrase. There's like songs based on it as well, talking about like the dark side of the moon. It says here, as a result, the moon does not seem to be spinning. It appears to observers from the Earth to keep almost perfectly still. So we are always looking at the same side of the moon. For people who study the moon and kind of know it in terms of its craters and its imperfections and kind of identifying features, I suppose, of different parts of the moon. It doesn't seem to spin, and that's down to its rotation. Okay, so I'm going to show you this video, which I think helps to explain it. So we'll just watch this. Okay, so that's the moon with no rotation. Okay, and as you can see, if that were the case, we would see all sides of the moon. Okay, so the next thing they're going to do is they're going to get the moon rotating. Okay, we know the moon rotates. We're going to get it rotating, but what I want you to concentrate on is the speed. Okay, so I'm going to count the rotations, or I'm going to try. 1, 2, 3, 4, 5, 6, 7, 8. Right, so that was almost 9 rotations of the moon as it went around. But is that what actually happens? What did we say? So the moon actually only rotates once as it goes around the Earth. It just makes one rotation. Okay, whereas in that little demo there, this moon made nearly 9 rotations. So that's also not right. So watch what happens when they make it rotate just once. So now that was one rotation. If we go back a little bit, sorry. I don't know which bit I'm in now. Oh, yeah. Okay. Okay, so the red bit is over to the right. Okay, so one rotation will get the red bit back to the right. So it's turning. It's turning. It's halfway around its rotation. And there you go. One rotation. Okay, so this red bit rotated around and back to here while the moon revolved all the way around the earth. And as a result, that red bit was constantly pointing towards the earth. And that's why we only see one side of the moon. Okay, it's because the rotation and the revolving are the same. They both take 27 days. And as a result, as the moon moves around us, we're always looking at one side of it. Okay, so that's why the days are important. Okay, so the moon reflects light from the sun. So we know this, we talked about this the other day. The moon is a non-luminous object. So the only reason we can see it is because it reflects light from the sun. It does not make its own light. Okay, as the moon orbits around the earth, one half of the moon is always illuminated by the sun. But from our view on Earth, we only see part of this illuminated section. Okay, and this illumination of the moon by the sun is how we get the phases of the moon. So that's why when you look up at the moon, sometimes it's a half moon, sometimes it's a full moon. And so here we have the phases of the moon. Okay, depending on the position. I'm going to go and show you a video that explains this better. But the phases, and you need to know these, okay? You start with your new moon here. Then you move to waxing crescent, first quarter, a waxing gibbous, full moon. Then you have a waning gibbous. This here is the last quarter, or sometimes called the third quarter. Then you have the waning gibbous, and then you're back to the new moon again. Waxing means it's getting, means it's getting bigger or thicker or wider. And then waning means it's getting thinner. Okay, so we'll have a quick look here at these. These are kind of cool. Okay, so it's going to work for me now. Right, so this is actually like the date. So on the 13th of January, so where are we now? Oh, yeah. Today's the 14th, 15th. So Wednesday, we had a new moon. Okay, the moon's unilluminated side is facing the earth. The moon is not visible. Okay, so look. So it's being lit from the back here, but it's not visible to us. And if you look at it in this picture, here's the sun. And can you see in this one here? It's lit on this side, but we're looking this way. So we are seeing the dark side. Okay, so if we were looking for this, sometimes you go out in the evening and it's really, really dark. And it's because it appears like there's no moon in inverted commas, but what's probably happening is it's a new moon. Okay, so then we'll move on. So it's jumped straight to the 15th there. So that's tonight. There's a waxing crescent. Okay, so the moon appears to be partly but less than half illuminated by direct sunlight. And it's waxing, So the fraction of the moon's disk that's illuminated is increasing, okay? It's getting wider, so it looks a bit nicer here. So this is kind of the idea. So what will happen is we will see like a sliver of a moon, and then over the days, it becomes wider and wider and wider into this crescent shape. So it starts as a very thin crescent, and then it gets wider and wider because it's waxing, it's growing. Okay, and back to the position, we're at this angle here now. Okay, we are at our waxing crescent, which is this angle here that we're viewing. Okay, now obviously you're moving all the time here. So that's why as the days go on, this little crescent gets wider and wider. So it'll start quite thin tonight, and then get wider and wider and wider as the days go on. Okay. So let's have a look at the days. So 16th, you can see you're getting more of a sliver there. 17th obviously is the same. And then by the 18th, we're into the first quarter. 1/2 of the moon appears to be illuminated by direct sunlight. And we're still waxing. We're still in the waxing phase. So the fraction of the moon's disk that is illuminated is increasing all the time. Okay, so have a look in here. So 1/2 of the moon is illuminated. We're just looking at it from an angle. So look, here's us looking. So we're looking this way at it, but 1/2 of the moon is being illuminated by the sun. Okay, we call it the first quarter because at that point the moon is a quarter of the way through its 27 days or its lunar month. Okay, so we keep going. So the 19th and the 20th, we're still in the first quarter. 21st, still in the first quarter. Now, 23rd, we're moving on to a waxing gibbous. The moon, the moon appears to be more than half illuminated. Okay, so we're gone away from it being half illuminated to more than half. Okay, so here it is here. The moon continues to wax. Remember, wax means, based on our view, it's growing, it's getting wider. Once more than half of the disk is illuminated, the shape is called a gibbous, and the gibbous moon grows fatter each night because it is waxing. Okay, so 23rd, sorry, I should show it to you here. So here's our waxing gibbous over here. You can see on the illuminated side that we're just more than half, slightly more than half illuminated. 24th, 25th, 26th waxing gibbous, 27th waxing gibbous, and then 28th you move to the full moon. The moon's illuminated side is facing the earth. So look, here's the illuminated side of the full moon, and it's facing us. So that's what we're looking at. So we see a full moon. When we see the full sunlit face of the moon, we call it a full moon. Okay, so now we're going to move over to the waning side. So the 29th, we have a waning gibbous. So you're going back. So this was more than half, this was half, and this was less than half. So this was less than half illuminated. This was half illuminated. And this one was more than half. So when you move around this side, it's exactly the same thing. It's more than half, half, less than half. It's decreasing. So they're waning. Okay, so the pictures look the same. You have more than half illuminated. The shape is called a gibbous. This is a waning gibbous, and it's going to grow a little thinner each night. So moving through the 31st, the 1st of February, and now we're into the third quarter, or the last quarter. You're back to the moon being half illuminated. So half of the moon is illuminated. But this time it's going to be getting thinner. So 4th of February, 5th of February, and then by the 6th, you're back to that thin crescent shape. But this time it's getting thinner and thinner and thinner. Okay, so now we have less than half the moon illuminated, and you're going to see that crescent, and that crescent this time will narrow and narrow as we go back. And that's it. So 9th, so I'm going to get as far as the 9th, so presumably the 10th of February you're back to a new moon. Okay, so that's your phases. So you need to know them. You need to understand the phases of the moon and what exactly is happening and be able to name them appropriately. Okay, so the last thing I want to do is eclipses. So solar and lunar eclipses. So the first one is solar. So in a solar eclipse, the moon passes between the sun and the earth. Okay, so here's the picture, and you do need to be able to draw that picture. That was slightly thinner. Okay, you need to be able to draw that picture. So here's the moon coming in between the sun and the earth, and then the moon is casting a shadow. So do you remember we talked about this the other day? Because light travels in straight lines, the light from the sun can't pass through the moon, so you get a shadow being cast. Okay, again, you can see these light rays traveling in straight lines, and because the sun is so much bigger than the moon, the earth as well, you kind of get this double shadow thing. So the really dark shadow in the center is called the umbra, and then the slightly lighter shadow on the outside is called the penumbra. Okay, but see that little bit there where the shadow hits the earth? That's where the eclipse is going to come from. So let's have a look. I have a video on this one as well. We'll watch this.
In a snap. Whoa! It's the middle of the day. So why is the sky getting dark? It's a solar eclipse. A solar eclipse happens when, at just the right moment, the moon passes between the sun and earth. Sometimes the moon only blocks part of the sun's light. This is called partial solar eclipse. Other times, the moon blocks all of the sun's light. This is called a total solar eclipse. As the moon blocks the sun's light, it casts a shadow on part of the earth. The moon's shadow creates a trail as the earth rotates. This trail is called the path of totality. If you want to experience total darkness during an eclipse, you have to be in the path of totality. In that path, the moon completely blocks the sun's light for a few minutes. It gets so dark that it looks like nighttime during a full moon. If you don't know what's happening, it can be confusing. Animals can get confused too. But this total darkness can also be kind of cool for scientists who study the sun's...
Okay, they go on to talk about other bits and bobs there, but that's essentially a solar eclipse. So the moon comes in between the sun and the earth. The moon casts a shadow on the earth. Again, you saw, because the moon is smaller, in order to experience a total solar eclipse, you have to be in particular parts of the earth. When I was looking for that video there, I can't remember what year. I think it's like 2026 is the next time a solar eclipse comes anywhere close to us, and it'll be in Spain. There's like part of Spain you could fly to if you wanted to experience the solar eclipse. So you have to be in, that path of totality to be able to totally experience it. Okay? And then we have the lunar eclipse, which you also need to be able to describe. So in a lunar eclipse, the earth passes between the sun and the moon, and this time the earth blocks the sunlight reaching the moon. Okay, and again, the picture is important. You just need to be able to put them in the right places. Okay, so for a lunar eclipse, you're eclipsing the moon, hence lunar eclipse. So the earth gets in the way, and it blocks the rays from the sun, and basically the moon passes into the shadow. And again, you get this double shadow thing where you've got the umbra, which is the darker shadow, and the penumbra. Okay, so I'm going to show you a video on this one too.
A lunar eclipse happens when the Earth blocks some or all of the sun's direct light from reaching the moon. This cosmic event only takes place during a full moon, which happens once every 29.5 days, or the length of one full orbit of the moon around the Earth. So why don't we have an eclipse every month? The moon's orbit is tilted a few degrees in relation to the Earth, so the Earth, moon, and sun don't always align. When the Earth does eclipse the sun, it casts two types of shadows on the moon. A larger shadow, known as the penumbra, and a smaller, darker shadow, known as the umbra. There are three types of lunar eclipses. The first is a total lunar eclipse, when the sun, moon, and Earth are in perfect alignment and the moon falls within the Earth's umbral shadow. Total lunar eclipses are the most striking of the three types because they turn the moon a sunset red. While shorter blue wavelengths of light are scattered outward by the Earth's atmosphere, longer red wavelengths are refracted or bent inward toward the moon, making it appear red. The brightness of the moon's red glow depends upon how much dust and clouds are in the Earth's atmosphere. Following volcanic activity, ash can block out enough light to render the moon a darker red or even near black. A partial lunar eclipse, the second type, occurs when the Earth, moon, and sun don't perfectly align, so only part of the moon passes into Earth's umbra. Earth's shadow appears very dark on the side of the moon facing Earth. Last, a penumbral lunar eclipse occurs when the moon passes through Earth's penumbral shadow. The event is so subtle that most people don't even notice. The moon will appear just slightly darker than normal. Lunar eclipses occur up to 3 times.
Okay, so that's your lunar eclipse. Okay, so all of the notes are there, and that is the chapter finished. So you need to know your phases of the moon. You need to know what happens during a solar eclipse and be able to draw a simple sketch of it. You need to know what happens during a lunar eclipse and be able to draw a simple sketch of it. And it's more about the order than, like, you know, it's a lot of geometry in these pictures with drawing the shadows and everything. It's more about, in a lunar eclipse, the Earth is in the middle. In a solar eclipse, the moon is in the middle. Okay, that's essentially what you need. So I have homework questions for you. There's 3 of them. They're paper questions. Yeah, so there's just 3 of them there. So I'll put them into the homework journal on OneNote, and I'll put up the thing in the collaboration space, the page in the collaboration space here, in case anybody has any questions. We'll call it chapter 23 part 2, in case anybody would like to ask me any questions. And yeah, that's it. Okay, so please let me know if there are any questions, but that is chapter 23 done. So well done, and have a good weekend.